It's an interesting fact that magnetic forces do no work on a charged particle. Doing work results in a change in kinetic energy, and we know that when a force vector points along the direction of motion, then an object speeds up. When a force vector points against the direction of motion, an object slows down. Because of the vector cross product V cross B, the magnetic force vector F always points both perpendicular to V and B, but in particular to the vector V, so it never points along the direction of motion or against the direction of motion. It is always sideways too. The work done by a force is defined as the integral of force dotted into displacement. So it's the dot product of F dotted into a displacement vector delta x. If we insert the magnetic force in particular, that is QV cross B, and that must be dotted into delta x. We can write delta x as a velocity times delta t. So in other words, the distance traveled in a short amount of time is v times delta t, and that equals dx. In this case, we are asking to take the dot product of this vector v cross b, which is a new vector, and v itself. Since v cross b is perpendicular to v, then the dot product has to equal 0. If there's no work, then by the work energy theorem, the delta k is 0. And this means that 1/2 mv squared is a constant, or velocity final equals velocity initial. Magnetic forces are just centripetal forces, like the string on a tether ball. They keep charged particles that are already moving in a circular path.